In this lecture, we're going to take a look at how we can find factors of a number. And there's really nothing particularly elegant or fancy about the approach we use. In fact, it's what mathematicians refer to as a brute force algorithm. We're just going to take 81 and start dividing it by numbers. I'm going to start at 1, 2, 3, 4, and so on. We're going to keep going, see which ones go into it evenly and which ones don't. Now, first thing you might think is, well, do I really have to do all of them? I mean, do I have to check every number from 1 all the way up to 81? Because that's quite a lot of numbers, right? Quite a lot of division we'd have to do here. And the answer to that is no, you don't. There's a quick rule of thumb you can use to know when you can stop. And what you do is you take the number that you're trying to find the factors of, and you do what I did down here. You take the square root of it. Right? Square root of 81 is 9, and that's telling me that I only have to check up to 9. Right? Once I get to 9, I've found all of the possibilities, and we can call it a day. All right, so let's try these out. 81 divided by 1 is 81. All right, 1 went into 81 evenly, so 1 is a factor. 81 divided by 2 is 40.5, not an integer, right? So 2 is not a factor. 81 divided by 3, that's 27, good. 3 is a factor. 81 divided by 4 is 20 and a quarter, so that's not one. 81 divided by 5 is 16.2, also not an integer. I'm not having a whole lot of luck here. 81 divided by 6 is 13.5, which is not an integer. 81 divided by 7 is 11.57 something. It's not an integer, so 7 is not a factor. And finally, 81 divided by 8 is 10.125, I think. Also not an integer. And the last one, 81 divided by 9 is 9. That one does work, right? So 9 is a factor. Now, I want to be clear of what we did here, right? 1, 3, and 9 are all factors, but those aren't all of them. The numbers that we got from doing the division are also factors. So 81, 27, and okay, here we got 9 again, are also factors. So if I wanted to write the complete list, I would say the factors of 81 are 1, 3, 9, 27, and 81. All right, so let's try another one here. Very similar number, right? I only changed it by just a little bit. All right, so let's see if we can find the factors of 80. Well, 80 divided by 1 is 80. So that is a factor. 80 divided by 2 is 40. That's good. 80 divided by 3 is 26.66 repeating. So that one doesn't count. 80 divided by 4 is 20. 80 divided by 5 is 16. 80 divided by 6 is 13.333. That's out of the running. 80 divided by 7 is 11.42 something, not an integer. 80 divided by 8 is 10. And finally, 80 divided by 9 is, let's see, it's going to be 8.88 repeating, also not an integer. All right, so what were we left with? Well, we got 1, 2, 4, 5, and 8, and don't forget the other numbers over here in the second column: 80, 40, 20, 16, and 10. So the complete list will be 1, 2, 4, 5, 8, 10, 16, 20, 40, and 80, right? A much bigger list. So put these two side by side, right? Just, for comparison. Um, you can see that despite those numbers being really close, right? They're only off by one. There was a significant difference in the factors that we came up with, right? So really, and that's the takeaway that I want you to get here. Um, you can't look at a number and look at another number that's close to it and say, well, in some sense, the factors should be close to each other as well. Two numbers that are very close can still end up with significantly different factor lists. So I got one more here for us to look at. I want to think about the factors of 17. And I'm going to use my rule here, right? The square root of 17 is 4.123. So I'm only going to go up to 4. Those are the only numbers I have to check. 17 divided by 1 is 17. 17 divided by 2 is 8.5. 17 divided by 3 is 5.66. And 17 divided by 4 is 4.25. So 2, 3, and 4 did not give me integers. So the only factors 17 has are 1 and 17, right? 1 in the number itself. All right, this is a special kind of number, right? A number whose only factors are 1 and the original number. That's what we call a prime number, right? We're going to talk more about those in the next lecture. So it turns out that these prime numbers that we were just talking about are particularly useful in a lot of different applications. So in the next lecture, we're going to start digging a little deeply into those numbers with an eye towards seeing the sorts of things that we can do with them. So if you like this lecture or just found it useful before you go on to that one, please don't forget to click the like button down below.